Hey guys, in this video we're going to go over a quick trigonometric proof. It's fairly simple to do, fairly straightforward. I know it looks a little, maybe a little bit above normal difficulty level, I suppose, of trigonometric proofs, but it's actually very, very easy to do. So if you just follow along, let's get this problem solving and let's help you get advanced at trigonometric proof identities. Okay, so let's get started. So if you take a look, we have sine squared x plus cosine squared x minus cosecant squared x all over 1 minus cosecant x is equal to 1 plus sine x all over sine x. If we take a look on the left side here, we have sine squared x plus cosine squared x, which is equal to the 1 because of the Pythagoras theorem. Sine squared x plus cosine squared x is equal to 1, which is pretty obvious. So if we take a look here, we can rewrite this equation as 1 minus cosecant squared x over 1 minus cosecant x, and that is equal to 1 plus sine x over sine x. Now I won't rewrite this anymore, but now let's focus on the left hand side here, and this is the right hand side. We'll focus on the left hand side moving forward. If we take a look at this, it's actually a perfect square because 1 times 1 equals 1, and cosecant times cosecant is cosecant squared. We also have a minus sign here, so we have a difference of squares. So we have 1 plus cosecant x times 1 minus cosecant x. So I'll just write that here, 1 minus cosecant x, and 1 minus cosecant x is at the bottom. And then if we take a look, we have cosecant x, 1 minus cosecant x and 1 minus cosecant x here. So we can cancel those out. That becomes 1. And we are basically left with 1 plus cosecant x. And if we also rewrite cosecant x as 1 over sine x, this becomes 1 plus 1 over sine x. That becomes 1 over sine x. And if we take a look at our final product that we need to get to, we have sine x at the numerator and 1 denominator. So 1 plus sine x at the top, sine x at the bottom. If we so we have to combine these into two terms into one single term. So if we combine with the common denominator, we can say the 1 becomes basically sine x over sine x plus 1 over sine x. That becomes all over sine x of sine x plus 1, and that is equal to, basically we can rearrange the 1 and the sine x, so all over sine x. In the denominator we have 1 plus sine x